Hello class, I'm going to make you work. I want to go through this again, just a reminder, and then have you do a little bit of work on your own. So just a reminder, binomial probability means binomial experiment, just two outcomes can happen. We have a fixed number of trials that we're looking at, and we're going to find the probability of a certain, the probability of a outcome occurring. So just a reminder, combinations, so you're going to have to use that. That's where you have to look at factorial. And n is the total number, x is the number of successes, or number that we're looking for. P is the probability of success, Q is the probability of failure. So going back to our example that we're working on today, the data from the Kids Court estimates that 80% of all children under the age of 2 are immunized. Right? There's an example of 25. We want to know what's the probability that exactly 17 children have been immunized. So that's what we're looking at. So first of all, we find probability. So we print out or type out what we got from the previous slide. So now we plug it in. P is the total number. So I plug that in. X is the number of successes, which in this case is 17. P is the probability of success, or the probability that they are immunized. Q would be the probability that they're not immunized. So you go through here. 25 is the total number. We want 17. There's an 80% chance, or 0.8, that they are immunized. We want to find 17 of them. If it's 80% that they are immunized and 20% that they're not, and then we go 25 minus 17. So when you do that, just a reminder, combinations, how you find them is it's the total, factorial, and then you go the total minus what we're looking at, factorial, and then the number of successes, factorial. So if I put that all down, it looks something like this. 25 factorial minus 25 minus 17 factorial times 17 factorial, and then 25 minus 17 is 8. When you go ahead and you do that, I simplify it all out. One thing I'd point out too is if you went 25 factorial, 25 on down, 17 on down, 8 on down, what you would end up with is this. 25 times 24 times 23 times 22, 21, 20 times 19 times 18 times 8, 7, 6, 5, 4, 3, 2, 1. If you did that, you would get about 0.06. So there's about 6% chance of exactly 6% chance of exactly 17 children being immunized. The other thing you're going to be looking at, and then we'll go through a sample, this is the easy stuff to me. Find the mean, the average. So you just take, to find the average, you take the probability of success, times it by the total sample size. To find standard deviation, a little bit different, but again, you find the average and multiply that by the probability of failure, and then take the square root of that. So write these down. You're going to need it. Max, write it down. So then we go to the public health agency, same example. Okay, we want to find the mean and standard deviation. So to find the mean, we multiply the probability of success times the total sample size. Total sample size is 25 times the probability that they are immunized, which would be 80%. So 25 times 80 gives you 20. So there are 20 children. The average would be 20 children that are immunized. If we want to find standard deviation, how spread out they are, we go ahead and go square root of your average times your probability of failure. So 25 times 0.8, and then 1 minus 0.8 is 0.2. If you did that, you would get about 2 children, a standard deviation of 2. So how far it varies? We'd expect a variance of 2, which is really what's saying is we'd expect all the children, we'd expect most children, or the average, we'd expect it to fall within 22 and 18. Add 2, subtract 2. So we'd expect the majority of the kids, or the majority of our trials as we looked at, would fall in between 18 and 22. So here's our example, here's the problem, off your homework, 6.8. First problem. It is estimated that in The 10% of teens between the ages of 16 and 19 were high school dropouts. A random sample of 5 people between the ages of 16 and 19 is taken. What's the probability that 4 of the 5 people were high school dropouts? So 10% is the expected outcome. We want 4. So we go ahead, same thing as before. We want to find the probability. So we're going back to this. So P is the total number. So I'll go here. So P is our total number, which is 5. The number we're expecting to drop out would be 4. The probability of success, or the probability that they fall out, is 10%. The probability they stay in school is 90%. All right, we're trying to find out how 4 is what we're looking at, what's probably at 4 dropout. So you go ahead, you do that. Same thing, 5 factorial. List it all out. So if you did this, so 5 factorial over 1 factorial times 4 factorial. If you did that, then you would go ahead and you would get 0.00045. So that's like not even, if you looked at not even 1/10%. So if you rounded that, that'd be, you'd say a 0% chance that you would get 4 out of 5 people who dropped out. The other 2 examples, what is the mean number of dropouts in the sample size? You take your sample size, multiply it by the probability that they drop out. So 5 times 0.1, which is about 0.5. So there's a half a person. You'd expect half a person to drop out of high school out of 5. All right, what is the standard deviation of the number of high school dropouts in the sample size? Again, we take the mean, the average, take the square root of the average times the probability that they would stay in school in this case. So N is sample size, P is the probability that they drop out, and you would get here 1 minus 0.1 is 0.9. So if you did that, you would get about 0.67 would be your standard deviation for that example. So you're going to work through the rest of it. Same idea using these. Pay attention to at least or more than. If they say at least 5 dropouts, then we'd have 5, or for this example, at most 2 dropouts, then we have 2, 1, or 0. And we'd want to find the probability of all those. So this is what your homework is. I want you working on it. You're going to have some questions. Work through all the stuff that you can. And we'll go over the rest on Monday.